Assalamualaikum warahmatullahi taala wabarakatuh and very good afternoon. My name is Muhammad Hafizuddin Hamis bin Halim and this is my group. My group has Daniel Ashraf, Nur Fatini Aina, and Abdul Aziz Muhammad, and we want to present to you about hybrid renewable energy system, the combination of the solar PV, wind turbine, and generator set. And first of all, um, we want to introduce the system where we want to integrate it and why we design it. And first of all, we design and we study a wind solar hybrid renewable energy system at Kampung Bukit, Temin, Langkawi in Kedah. This location is also located in rural areas. The system aims to provide reliable and efficient electricity to a rural community using um, wind turbine, photovoltaic panels, solar panels, batteries, and diesel generator. The system is simulated and optimized using the HOMER software, and the results show that the system can cope with variation in solar and wind resources. And go through to the background. The project background is the wind solar generator hybrid system can is the combination of the solar panels, wind turbines, and the generator to produce reliable and clean electricity. These systems are more efficient, reduce fossil fuels, lower carbon emission, and provide better power quality than a single source system. They are suitable for off-grid, microgrid, or on-grid, and grid-connected application consisting of components like solar PV, wind turbine, generator, energy storage, and controller. Um, and the system we study is suitable for the rural areas like Kampung Bukit Temin at the Langkawi, and we use the to design and to optimize this system using HOMER software. This software helps us to analyzing the cost, the reliability and the performance, while also evaluating the impact of different condition and different parameters. And then we go through to the problem statement. We have three problem statements. And first of all, the converting them to electrical energy in power plant has a severe impact on society and the environment, including air and noise pollution. The increasing is global demand for energy, along with environmental concern, has resulted in a considerable move toward renewable energy. And the last one, the concept of hybrid renewable energy system, which combine two or three types of renewable energy sources, has arisen as a method for increasing reliability. Okay, and then we go to the objective. We have three objectives. First of all, we design the hybrid renewable energy using HOMER software. And the second one, we want to evaluate the performance of hybrid renewable energy system. We want to evaluate the performance, the system that we have designed. And the third one is we want to evaluate the societal and environmental impact of the hybrid renewable energy. We want to evaluate if this system is suitable or not to to integrate in at the rural areas, which is Kampung Bukit Temin at Langkawi.
Hi, my name and my matriculation number are as displayed on the screen. I will be presenting the methodology of the project. The methodology of the project follows a systematic process as shown in the flowchart. Preliminary calculations were conducted to estimate the energy demand and evaluate the renewable energy potential. Load profile data was then determined based on the project location and input into HOMER software to design the hybrid energy system. After designing the schematic configuration, various scenarios were simulated to identify the most feasible solution. If HOMER did not produce a feasible configuration, troubleshooting steps were applied to refine the inputs until an optimal system was achieved. Preliminary calculations determined the energy contribution of each component in the hybrid system. The diesel generator contributes 50% of the annual energy output, solar PV provides 35%, and wind turbines account for 15%. Together, these components meet an estimated total annual energy demand of 252,420.48 kilowatt-hours, which is sufficient to supply energy to 80 residential houses in the selected area. The project focuses on Kampung Bukit Temin in Langkawi, chosen for its strong potential in solar and wind energy. The site experiences an average solar radiation of 5.09 kilowatt-hours per square meter per day and wind speeds of 4.26 meters per second, which are ideal for renewable energy generation. The daily energy load profile was estimated by multiplying the energy consumption per hour by the total number of houses in the area. This calculation resulted in a total daily energy consumption of 701.168 kilowatt-hours, with a peak daily demand of 80.384 kilowatt-hours. The proposed hybrid system consists of 5 main components: solar PV panels, wind turbines, a diesel generator, batteries, and a converter. Solar panels and wind turbines generate DC power, which is converted to AC power using an inverter. Excess energy is stored in batteries, while the diesel generator acts as a backup energy source. This setup ensures energy reliability even during periods when renewable sources are insufficient. The feasibility of the system was evaluated by considering costs associated with each component, including initial costs, replacement costs, and operating and maintenance costs. For instance, the cost of a 1 kilowatt wind turbine is Rm 7,000, while a diesel generator costs Rm 40,000 per unit. The project assumes a lifespan of 25 years, a discount rate of 8%, and an inflation rate of 2%. Key economic metrics, including levelized cost of energy, LCOE, net present cost, NPC, capital expenditure, CAPEX, and operating costs, were calculated to assess the system's overall viability. Using HOMER software, multiple hybrid system configurations were simulated over an hourly time series for 1 year. The optimization process identified feasible configurations by analyzing variables such as PV capacity, wind turbines, battery storage, and diesel generator output. Each configuration was ranked based on energy costs. 8 scenarios were considered, ranging from systems with all components to configurations with only 1 or 2 sources. For example, Scenario A includes solar, generator, and battery, while Scenario H integrates solar, wind, and a generator. This analysis helped identify configurations that balance energy reliability, sustainability, and cost. That concludes my part of the presentation. I'll now hand it over to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Daniel Ashraf bin Jasni, and today I would like to present the result simulation for our mini project of electrical energy system. The topic of hybrid renewable energy system using HOMER, that is show the combination of solar PV, wind turbine, and genset. As you can see, the first figure shows the bar chart that the energy productions of the source that I mentioned before, the wind source, PV source, and from the genset. And the table below shows the productions of the energy. For example, the PV produce 1469 kilowatt hour per year. That shows 14.9% from the overall project. And the genset 7625 kilowatt hour per year. That use 76.4% from the overall project. And the last one from the wind turbine that produce 860 kilowatt hour per year. Next, I will continue with solar power output. As you can see, the figure and the table that I provide for you is for the PV power output that we detect from 7 am to 6:45 pm. The power detect from 0.3 kilowatt until 0.8 kilowatt, and the peak around 12 noon. And from the table, as you can see, the rated capacity of the PV solar is 1 kilowatt with the main output 0.17 kilowatt, and the main output per day is 4.09 kilowatt hour per day, with the capacity factor PV is 70%, and the total production in annually is 1,469 kilowatt hour. The PV operates for 4,379 hours annually. Next, I will continue with the power output of wind turbine. As you can see, the table and the figure that I provide for you shows the wind turbine generate around 1 kilowatt in ideal conditions and produce average for 0.0982 kilowatt per hour, and it also produce 860 in annually. But when its capacity reach around 9.82%, it's efficient generate during operational hour, but it's not satisfies for the demand's needs. So its competitive levelized cost is 7 ringgit 25 cent per kilowatt hour, and its wind penetration is 20.9%, and it's made valuable to contributor to diverse the local energy source for sustainable practice. Next, I will continue about the last energy production our main project, which is the generator. As you can see, the table and the figure that I provide for you is for the power output of generator. The generator operates for 305 hours a year and generates 7,625 kilowatt hour when its capacity factor is 0.87%. With it mean electrical output is 25 kilowatt, and it can be ranged around 5 kilowatt to 25 kilowatt. And throughout this project, its lifespan is 21.3 years, and the full consumption that it will be reached is 2.783 liters, with specific fuel consumption is 0.365 liter per kilowatt hour. The efficiency of generator can be shined through its mean electrical efficiency when it be 27.8%, with fixed generator cost set at 11 ringgit per hour, while marginal generation cost is 0.253 per kilowatt hour, with levelized cost of its energy for this generator is 3 ringgit 77 cents per kilowatt hour.
Assalamualaikum. My name is Abdul Aziz Muhammad bin Abdul Aziz. Okay, for the societal and environmental impact, number 1, reducing poverty. Hybrid energy project create jobs, especially in rural area, helping people earn a living and improving overall economic condition. Number 2, better health. By moving away from a dirty energy source like petrol and firewood, we can reduce air pollution, leading to healthy community with fewer respiratory problems. Number 3, environmental protection. Hybrid system use renewable source, which are cleaner and more sustainable, helping protect the environment and its resource. Number 4, rural development. Investment in renewable project often mean improved infrastructure and facility in rural area, contributing to better living condition and economic growth. Positive environmental impact for the solar. Number 1, reduce air pollution. Solar power is clean energy that doesn't make our air dirty. It helps city by reducing pollution and making the air is healthy. Number 2, solar panel can be recycled. When solar panel made the component like silver and silicon reach the end of their 13-year lifespan, they can be recycled. This means that recycle extend the benefit of solar panel, giving their material is a new life. For negative impact, number 1, habitat loss. When increased air and noise pollution during construction, and negative effect on animal. Number 2, alteration of land use. Because between 3.5 and 16.5 area per megawatt can lead to land degradation and make it challenging to restore the land to the original condition. And number 3, exposure to hazardous material, for example, acid and chemical. And last, pollution of soil, air and water resource. Through land clearing, soil erosion, and improper disposal of chemical during construction impact to air, water and land quality. Positive environmental impact for the wind. Number 1, reduction of water consumption. Using less water in power plant, especially in processes like condensing and fuel cleansing, is crucial for conservation and allow for alternative use. Number 2, reduction of carbon dioxide emission. Wind energy creates minimal air pollution, emitting significantly less CO2 than fossil fuel-based power plant, and unlike fossil fuel, it releases no harmful pollutant like carbon dioxide, sulfur dioxide, mercury, and particulate is life cycle. For negative impact for wind, number 1, impact on wildlife. Wind turbine farm can affect wildlife by causing collision with blade, disrupting communication with noise, displacing habitat during construction. Number 2, noise impact. The primary environmental concern with wind turbine is noise pollution. And number 3, visual impact. Wind turbine farm can change the way an area looks, which may bother some people. Positive environmental impact for the generator. Number 1, cleaner option available. Modern genset with improved fuel efficiency and lower emission help reduce environmental footprint. Number 2, less resource intensity in certain cases. Efficient genset can use less fuel than model older because it's easy to replacing outdated equipment. For negative impact, number 1, greenhouse gas emission, and number 2, air pollution, and number 3, noise and vibration, and number 4, fuel dependency. Okay, for the conclusion, number 1, achieving in design and implementation. Successful synergy is achieved between wind turbine and photovoltaic cell for a reliable power supply. And number 2, efficiency and dependability of the hybrid system. Performance evolution demonstrates balanced energy output. And number 3, contribution to renewable energy technology. Valuable knowledge added to the field, offering insight for cleaner and more sustainable energy source. And number 4, toward a greener and sustainable future. The successful integration of solar and wind technology highlight a promising solution for challenges associated with conventional energy source.